2024 question 7 begins with statistics. The ages of people who stayed in a hotel, normally distributed. So we're going to draw a normal distribution curve. Mean of 48.2 in the middle. And standard deviation of 10.6. Find the probability they're less than 50. Well, 50 is above 42. So we're looking for the area under the curve here, or we're looking for a z-score. Our test statistics, this statistic, tongue twister, minus mu over sigma, 50 minus 48.2 over 10.6 gives me 0.17, so I need to find its z-score. Here's my z-score table. 0.17 is 5675. 0.5675. In part 2, exactly 10% are at least 8 years old. So let's do another sketch of that. So if they were at least 8 years old, where would they be? Well, if they're here, if they're at least less than 48, let's say they're at least 30. 10% are at least 30. Would that make sense? No, because all of these guys are over 30, so that we're looking for is over here. So maybe at the higher end, maybe 48.2, 50 we found was 56%, so it's going to be, let's say 60. If at least 10% are 60 years old, it will be the little tail in here. So we're looking for 90% at this point if there's 10% in the tail. So we need a z-score of 0.9, which is on the next page. 0.9, the closest to it, 0.9, this one's closer. So that's 1.28 for a z-score. So our z-score is equal to 1.28. So we're testing x, we'll call it a because they call it a in the question. A minus 48.2 over 10.6 is equal to 1.28. So a is equal to 10.6 times 1.28 plus 48.2. This is giving me 62 years old. We estimated 60, not bad. 62 years old, or 62 years young. Now what are we doing over here? Bernoulli trial. During a most recent stay, 1/5 used the pool, 0.2 used the pool, so 0.8 didn't. We have our success and failure for our Bernoulli. 6 are picked at random. Find the probability exactly 2 used the pool. 6 choose 2 by 0.2 to the power of 2 by 0.8 to the power of 4. If you don't know your Bernoulli trial rules, you probably aren't watching this video. This gives an answer of 0.24576. One of these maths questions, when you practiced it, you look at it, you get it in the exam, and you have a big smile on your face. Now we're told n of them are picked at random. The probability none of them use the pool. So we could set up a Bernoulli trial, but if none of them use the pool, there's no successes. So it's just failure. We don't know, it could be to the power 10, 20, 30. N, or x, whatever you want to call it, is the answer to this question, is 0.0047. So n by the log or natural log of 0.8 is equal to the log of 0.0047. So n, just write out the steps, log of 0.0047 over the log of 0.8. This is giving me 24.02. I'll just say 24 for n. And then the next part is a tree diagram. So 45% is the first branch of the tree. They log on to the old booking system. And 55% obviously is the other side of it. They log on to the new booking system, 55. So we have old and new. 1/3 of the people on the old system book a room, 1/3. So just call this 1/3. We don't need the 2/3 part actually here, so I'll just leave it out. And on the new booking system, 2/5 book a room. So how many book a room? Well, this is going to be 9 over 20, 0.45, 9 over 20 by 1 over 3, or just use a calculator, it's probably easier. That's 3 over 20, or 0.15, and this one is going to be 11 over 0.55, 11 over 20, 11 over 20 by 2 over 5, which is 11 over 50, which is 0.22. And because we started out kind of nearly like they're adding up to 1, we can say that, well, that's kind of like 15 people booked the room and 22 people booked the room. So 37 people booked the room overall. And we're asked for the probability that the person used the new booking system. Well, 22 of them booked the room from the new booking system. So it's 22 out of the total 37 by 100, which is equal to 59%. So nice, easy questions in 2024 so far. In 2020, they were rated the best hotel chain by 75% of their customers. A random sample of 1,000, if n is equal to 1,000. And 765 of these, so 765 out of 1,000, which is now 0.765, booked the room or rated it the best. Carry out a hypothesis test to see if there's any change. So our null hypothesis, 75% of customers still rate PK the best. And the alternative is 75% is not the average, or not the percent of customers ranking PK the best, something along these lines. You can imagine the examiner is going to read something that's half right and give you the marks. So there's two ways to do this. We can do 1.96 times the square root of 0.765 times, that's p, and 1 minus p will be 0.335 divided by n, 1,000, and we could add this on to 0.765, and we could take it away from 0.765, and I'll do that quickly on a calculator. That's going to give me, the higher end is 7.791, and at the lower end I'm going to get 0.738. So our test statistic is between 0.791 and 0.738. Therefore, in the conclusion, no change, except null, if this is the way you set it up. They'd also accept a margin of error here. 1 over the square root of n is my margin of error. 1 over the square root of 1,000 is equal to 0.0316. Probably shouldn't make a difference. We'll just take the 0.03. So we'd say 0.765 plus 0.03 and 0.765 minus 0.03. So we're going to get 735, 0.735 less than or equal to p, less than or equal to 795.795. You can see these numbers are very similar. If you haven't mastered statistics and hypothesis testing and there's 20 marks for this part, you are not at the races.